So I feel slightly outnumbered today on today's episode of the podcast because, well, for something a little novel that we used to do at the very beginning, but we haven't done for a little while, is we have a guest on the podcast. But before we introduce our guest, I'm actually going to pass the baton to Sven, because I feel a little outnumbered in people who speak French today, and I'm not going to attempt the pronunciation of our guest's name. So Sven, would you like to introduce our guest?
I was racking my brain while you were talking, thinking, what would Marc and I have in common? And then I'm giving away part of his name already. It's Marc Prud'hommeaux, who's joining us today to talk about Swift on Android. You've completely dumped this introduction on me, Dave. Thank you.
Well, I didn't want to embarrass myself with my attempt at the pronunciation, because I am not a French speaker, unfortunately. I wish I was, but I'm not.
Well, hello, everyone, and fantastic pronunciations, man. I'm very, it's better than I think I've ever heard it.
Thank you.
I was also very impressed. The reason I dumped it on Sven was I knew he'd do a good job with that. But welcome. Thank you so much for joining us.
Yeah, thank you for having me.
So I think the best place to get started is for you just to give a little introduction of who you are and what you do.
Yeah, okay. Well, my name is Marc Prud'hommeaux, as we would say in English. I am a developer. I've developed in a wide variety of languages and technologies over my career, but past 15 odd years, I've been predominantly an iOS developer. I've started a company a couple of years ago called Skip. And the vision is to enable people to write their applications in Swift and be able to deploy them to both iOS and Android.
It's really nice to see Swift growing into multiple other platforms, and it will be no surprise that we chatted with Marc before we added Android support to Swift Package Index, which we did a couple of months ago now, because Marc and the Skip Tools team had made an independent website that was starting to test compatibility with Android packages, or Swift packages compatibility with Android. And you were running that as a separate site, weren't you?
Yep. Yeah. It was Swift everywhere. And it was just sort of running GitHub Actions that was more or less trolling through, the popular packages and seeing, does this build for Android? And if not, what are the errors? And then very often I would go through and I would try to resolve the errors and submit pull requests to the projects. And it was kind of a personal project to be able to promote the usage of the Swift Android SDK and be able to kind of build up more compatibility with some of the popular projects out there.
And as you can now see on the site, we do have we actually added two platforms at the same time. We added both Android and WASM compatibility checking. But just to stick on the Android for a little bit, and we'll talk more broadly in a second. But apart from checking the build logs that we do publish when we do all our platform builds. So if you haven't seen this feature of the Swift Package Index, if you look at the full build results of any package, you can then click through to the build log, and if there was a failed build, we will attempt to show you the build log. But so apart from looking at those logs, is there anything that package authors can do to help themselves become more compatible with Android?
Yeah, well, in general, the first step, so, sort of to step back a little bit, the Swift Android SDK is a cross-compilation SDK. So it's similar to the static Linux, the MUSL SDK, and the WASM SDK. And it's a SDK that adds on to the host toolchain in order to allow you to build on a host platform, in other words, Mac or Linux or Windows, for a different, another platform. So for example, with the static Linux SDK, you can build on Mac OS for Linux. And with the Android SDK, you can build on, Mac OS or Windows or Linux and cross-compile to Android. And in general, building for Android you run into a lot of the similar issues as you would building for Linux. Very often, if there's like a low level, libc kind of function or something like that you're using, where maybe you would import Darwin on Mac OS or iOS, you would, need to import glibc on Linux. That's usually with a conditional, like if can import Darwin, if can import glibc. Android adds another one to that, which is Android. So you can cover a huge swath of those sorts of issues by just doing, if can import this, if can import that, and then conditionally importing them. Generally speaking, if your package can compile for Linux, it's almost certainly going to be a pretty short, small amount of work in order to get to build for Android.
You're actually getting at a question that was sort of forming in my head as you two were talking, is how different is the Android SDK to Linux actually? If you were to boil it down, it sounds like it's almost as if there was a different kind of, we have this muzzle and glibc types of Linux. Is Android sort of, could you consider it to be a variant kind of like those?
Yeah. So Android is Linux. It's just not GNU Linux. They have a different libc. They call it Bionic.
Yeah.
And it's pretty compatible. Like they have almost all the same functions. You can call ABS and cosine and, fopen, fclose, things like that. But generally speaking, it is not exactly the same. And that's why you have a different set of headers that you import for the kind of low level stuff. And so, yeah, it's very, very similar to sort of the difference between the static Linux SDK and actually compiling for Linux, where in one you import glibc and another you import musl.
And so, was it a particular itch you wanted to scratch yourself when you started delving into Swift on Android? What was sort of the motivation for you to try and do this?
Well, the overarching goal is essentially to be able to, the holy grail of mobile app development is to be able to use the same language to build an application for both platforms. And this is something that, I have always been dissatisfied with the current state of affairs. There's been a lot of iterations of this sort of thing. In the olden days, we had, like Cordova and things like that were just sort of like, web views that you can code in JavaScript. More recently, the popular packages are things like Flutter and React Native, where you write your app in Dart or JavaScript. But these all have a tremendous number of shortcomings that I think are pretty well understood, and they don't really embrace the native platform APIs. So the very high level goal was, we want to allow you to write an application in a single language. And we love Swift. Swift is a fantastic language. We think it's ideal for application development. They say it's, all the ease of Java with all the efficiency of C. It's really ideal for this scenario. So that's really where we come from, is we want to enable people to build their applications for the two major mobile operating systems out there. And everything else is really a result of that. The whole are joining the Android work group and all our iterations on the SDK and the tool chain. And all of that is in service of this larger goal.
And how practical is that today?
It's very practical. People are using Skip to build and ship applications, currently. It does all work. The sort of official, so we ourselves, Skip, are publishing our own tool chain right now, our own SDK, that is essentially the exact same SDK that is eventually going to be the official one that's published on swift.org. And we also have a lot of tooling that is built on top of it, because just having a cross-compilation SDK is only one small real piece of the whole picture of actually building an application with, graphical elements and integration with system APIs and things like that. Yeah. But yeah, no, it's up and running today. Things work really well. There's kind of two modes that we run in. We have something called Skip Lite, which was our first iteration before we had the whole Android tool chain, where instead of actually compiling your Swift on Android, we transpile the source language to Kotlin, which is Android's sort of its own native development language.
Right.
And then that has really evolved into the current offering, which is called Skip Fuse, which takes those two concepts, the transpilation in order to integrate with Kotlin APIs, plus the native Android SDK, and bridges them all together so that you have all the benefits of writing all your application in Swift, but you can still talk to all of the Android APIs, which are all in Java and Kotlin.
Right. So actually, and I wanted to clarify that when you use Swift on Android to develop an app, you are actually, like, the GUI is a native GUI, right? It's not like Qt on Mac that sort of has UI elements that look Mac-like, but aren't actually.
Yep.
To my knowledge, last I checked, it was sort of a different, it was a made to look like Mac UI, but wasn't truly Mac, was redrawn effectively. But this, you're saying, this is using actual Android native UI elements. Is that right?
Yeah. So these are sort of genuine native user interfaces on both platforms.
Right.
And that's the thing that we feel like no one has really succeeded with. You look at Flutter apps and things like that, and they draw the pixel, they paint the pixels onto a canvas, and they kind of mimic, iOS with their Cupertino theme, and they mimic Android with their Material theme. But, they pretty quickly, even a non-technical user identifies, like, the scrolling is not
always
feel right, it's a little delay, the font rendering. I mean, just a million things that are so obviously apparent, maybe not from screenshots, but the minute you start using an application.
Yeah.
And so that was really a hard requirement for us, is that it needs to be actually native on both platforms.
And I think it's the right requirement as well, because I think it is really just very important to for that platform look and feel, especially the feel, actually, more than the look, that it is using the native libraries. And it's an approach that Salim used with the Windows integration libraries. They were, when I first saw that project, I kind of assumed that it was going to use SwiftUI and then kind of mock up the SwiftUI on Windows, but actually it's not that at all. So the Swift WinRT packages hook into the native Windows APIs rather than trying to do cross-platform UI.
Yeah, exactly. And we just feel that, you look at all the best-in-class applications, even the ones made by, Google and Facebook, who run the Flutter and React Native projects respectively, they all write their applications twice, once in, Swift and Objective-C for iOS, and another time in, Java and Kotlin for Android. Because of that, you just cannot get that premium feel if you're not using the native toolkits. And where Skip kind of has an easy time is that on the iOS side, we're just using unintermediated Swift UI. Like, we don't stand in between you and, real Swift, because we're not really doing anything on iOS. It's on Android where we take your Swift UI and we translate that into the equivalent native calls using what's called Jetpack Compose, which is kind of Android's equivalent of Swift UI, and which is their recommended, native toolkit for building Android applications. So we really only have half that problem to tackle, which doesn't mean that it's easy. It's actually extremely difficult in many ways, but it means that we only have that side of it to really have to, nail down all the features and all the polish.
Right. And that sounds like there's a bit of gluing together that you need to do in instrumenting the APIs, right? Then that sort of leads me to the question, how ready are there any types of apps that this is particularly suited for? Are there any gaps you still have to sort of, fill in, or what's the overall state in what kind of apps you could be targeting?
Yeah. So we have a very large percentage of the Swift UI API covered, where we, translate it into the equivalent Jetpack Compose and native Android UI. If your app can use primarily stock Swift UI components, things like line of business applications, things like that, then you're going to have a really good experience, because you don't really have to go off the rails. You can just write it as if you're writing your iOS app, and then Swift takes, Skip takes over, and handles that for Android. It's when you have a lot of sort of custom components, if you need to drop down to like UIKit or need to use a lot of Apple only frameworks, that's where you need to sort of delve into some of Skip's extensibility options for being able to implement some of that yourself. And that's when you need to start thinking about doing a little bit of your own work in Kotlin, which is kind of a leap in terms of the complexity of integrating this stuff.
Right, and it sounds like you have escape hatches, so you're not lost. You don't have to abandon your project if there's stuff you can't do. You can still escape hatch out on the Android side into native Kotlin, and obviously on the Swift UI side, escape hatch out into the UI and still have the same app. You probably just if it somehow. I guess you have a mechanism.
Yeah, exactly. We have a series of sort of escape hatches that go in incremental complexity degrees. But the simplest one is the one that we're most proud of, which is you can just type, pound if skip and just drop some Kotlin right into your Swift. And then,
nice. Okay.
else, if not, and then the skip build, the Xcode build plugin will handle taking that, extracting it from your Swift, putting it out in the Kotlin, and then building the bridge for you so that the native Swift is able to communicate back and forth with the custom Kotlin that you drop into your code. And then you can use that as the entry point to accessing, the whole ecosystem of Kotlin libraries that exist, in the Android world.
You mentioned SwiftPM plugin there. Is there some machinery that is particularly useful from the whole compiler and SwiftPM toolchain that makes this possible at all without a lot of extra instrumentation?
Yeah, no, the whole build plugin system, Skip wouldn't be possible without it. Because the way Skip works is, you just work in Xcode and you develop your app and you build and run it and it launches it on the iOS simulator as normal, but it also launches it side by side on the Android emulator. So you can iterate on these two things side by side. And you don't have to really interview. You don't have to launch any other tools. You don't have to do anything. And it's the magic of the build plugin that does all this. Every time you change any of your Swift, the build plugin picks it up. It does all the necessary bridging. It writes out, it does any additional massaging it needs to be able to launch the Android tool chain to build it natively, packages up your application, puts it on the device or the emulator, and then runs it. That's really all handled by the build tool plugin. So without that, it really would not have been nearly as smooth a process. You'd need to be having extra steps where you go to the command line and launch external tools and things like that.
That sounds great.
And coming at this from the other side, there is, of course, Kotlin multi-platform. How do you feel about Kotlin multi-platform?
Yeah, so we've worked with that actually quite a bit. Skip in some modes does actually integrate somewhat with Kotlin multi-platform. But for the most part, you can kind of view Skip as the inverse of Kotlin multi-platform, where they have a mechanism where, they take Kotlin and they build it's just your regular Kotlin in the Android development side. So it's not doing anything there. But when you deploy on iOS, what it does is it creates essentially Objective-C wrappers around that Kotlin, and it compiles it for iOS. And then you sort of have an XC framework that you hand off to your iOS developers, and you can use it to implement sort of the business logic of your application. You'll still be writing the two user interfaces separately, one in Android Studio and one in Xcode, but you'll be able to share a lot of the low-level logic. So in many ways, Skip is kind of the inverse of that process when all you're using Skip for is sharing business logic. But then in addition to that, you can also use Skip for the whole sort of vertically integrated user interface side as well,
right?
Which Kotlin multi-platform doesn't have quite the same experience around.
Sure. I think the other thing we wanted to talk about today was the recent announcement and founding of the Swift on Android work group, which is it yet an official? I know originally it started as a community work group. Is it now an official Swift work group?
Yeah, it is. And I should sort of rewind and say that we at Skip did not invent this idea of Swift on Android. People have actually been working on it for over 10 years. Ever since Swift came out, people have been thinking, you can kind of tinker with the Android native development toolkits, LLVM and things like that, and you can get Swift running on it. So it's been kind of evolving with disparate groups of people with different, needs and levels of hobbyist versus professional needs. and it's been progressively evolving, but it never really came together in a cohesive whole where everyone was sharing this, sharing ideas and implementation efforts. And that's something that we started back in February with what we called the community work group. And that was a bunch of us, Johannes, Andre from Riedel, who's been deploying Swift on Android with the popular Riedel Spark mail application for quite a long time. He's one of the people that really has done a lot of work on getting the Android SDK working. Affinigolfin, who has been just devoted, to it for a long time. So the sort of group has all come together and decided, okay, we're just going to, pool our resources and we're going to focus on this. And of course, Salim from the browser company, they're also working on this. And so we formed the community work group and then, pretty quickly proposed that it be made official, which it was a couple of months ago in June 25th. So almost exactly 2 months ago, it became an official work group. And the goal there is not near, as ambitious as any of our individual projects, which are using Swift on Android, for our own, individual needs. Skip, obviously, to enable people to build applications for both platforms, but other people just to include in their own individual applications. It's really more to get an official Android SDK kind of published alongside these other cross-compilation SDKs like the Musil and the WASM SDKs, and establish it as an officially supported platform for Android.
That's great.
Yeah, is there, like in the work group, is there anything in particular you have on your sort of to-do list that you feel like you need to tackle? Any specifics there that you can share, that you want to share?
Yeah. I mean, so there's a lot. So, the first sort of deliverable that we're on the verge of getting out there is an official SDK where you can, just like you can cross-compile from macOS to static Linux, you'll be able to cross-compile to Android. But that's really only a single piece of the whole Android story, right? What do you get out of that? You can get an executable Hello World application that you can just, run on Android. Or you can, create a shared object file, which you can then embed in your Android application and then access. But filling in the rest of the story is a pretty large, sort of next step. For example, how do you handle resources on Android? It's different than resources on Darwin. How do you handle bridging? The reality, of Android is that it is a Java-based platform. Almost all the APIs that you need to talk to the system, to the device sensors, to Bluetooth, to GPS, are implemented in Java. So you can't just do that with C bridging. You need to bridge across to Java and Kotlin, which is, a pretty complex topic to begin with. And then on top of it, doing it efficiently, for a mobile application is an additional complexity. So we've actually been working with the Swift Java team, mostly Conrad, on starting to come up with some baseline interoperability standards and recommendations for how Java is going to integrate with Android, along with the other deployment scenarios for Swift Java, which is, largely server-side integration. So that's a really big one. And then just the whole story around, packaging, IDE integration, debugging. There's a whole world of kind of next steps in order to complete the project. Now we sort of at Skip have our own solutions for a lot of these things. We integrate with Xcode. We handle bundling in our own way and things like that. But the more that we can get that, worked out in a standardized way where everyone who's using Swift on Android will kind of do it in the same way, really only helps, all of the community in order to have, the right way to do this.
And how has feedback from the community been to the work group?
Great. People are really excited. There is a lot of, sort of what next kind of questions because, as I mentioned, the output of the current SDK is here's your shared object file, go at it. And then people are like, well, how am I supposed to talk to this from my Android app and things like that? But it also has, I mean, there have been a tremendous response to the announcement. A lot of people have joined in the work group meetings with feedback on what they want to use it for, what they are currently using it for. A lot of people we had never heard of who have been sort of using it in their applications in various ways have cropped up and had really good suggestions and contributions.
So your workgroup meetings are open to the public, are they?
Yep. They're open. If you look at the Swift Workgroup Charter, we have the schedule there, and people can just drop in and ask questions or offer contributions. It's been a really good process so far.
That's great.
How often do you meet?
We meet every 2 weeks.
So quite a good cadence to see new stuff happening in the Swift on Android ecosystem.
Yeah. Actually, we have another meeting tomorrow.
I keep going back in my head to my earlier question, how Swift on Android is sort of different from Linux. And as you talk and keep talking about then Java stuff, it feels like it's almost like this isn't the right. It's like on the Apple side, this was Swift for iOS, right? Because you immediately associate with Android. An Android app is a mobile app, right? It's not the Linux kind binary. As you said, the shared object file doesn't give you anything. It's like if on iOS you had I mean, there's no terminal, but had a little binary that ran without any UI. That is not an app in the sense that is useful for the platform. So it's kind of makes it obvious what a big task it is to have not just the plumbing to get the code on there, but there's all the user facing stuff that needs to be there and needs to happen. That's super interesting.
Yeah, definitely. Like, sort of on Linux, you can imagine, I know there's a project to have bindings to GTK, one of the popular Linux, graphical toolkits.
Yeah.
And, with that, you can just build an executable, and link it to those bindings, and then you can have an application come up on the screen. It's all in C. And so you're going to be able to kind of access the world that way. But Android applications are sort of the mirror of iOS applications. They're packaged in a very specific way. They're launched in a very specific way. It's not just an executable. It's a whole, there's resources that are bundled with certain conventions. There are, derived resources like translation files and things like that. So it's really more of an application environment that you need to think about how you're going to integrate with. And that's where it really gets tricky. And to do it in a way where it doesn't feel like you're force fitting some alien technology into Android. And that's why, it's all done using the fairly standard Android native development toolkit mechanism that's used by any application that uses any native code, which is, largely games, but, many applications have some requirement for native code because it's just faster and you can avoid the, garbage collection, hangs and things like that.
Yeah, I mean, the whole thing, it's like, despite next year being the year of Linux on the desktop, the command line is sort of a very default user interface for Linux apps. So having just that, which is what Swift gives you by default, server-side Swift, that's all of it. That's a huge ecosystem on Linux, right? And, the bindings you mentioned, there's not, you even have to, there's no default UI binding for Linux, right? There's GTK, there's Qt. I'm not sure what the sort of, in quotes, market share is for either. And there's more than those two. It's, on Android as on iOS and macOS, the story is different, right? There is a default user interface that everyone thinks of if you talk about an app on those platforms. And I find it fascinating how they have different aspects there.
Yeah, absolutely. And so, on Linux, I think Qt and GTK have more or less half and half kind of distribution, one being the default for GNOME and one being the default for KDE.
Yeah.
But you have the benefit of it can just be a self-contained binary. And as you say, command line tools are also, probably the majority of Linux applications that you wind up running. And so you kind of, Swift has a very natural fit there because you can just sort of pull in all these packages. Yeah, and your user interface is the Swift, argument parser, really.
Great. Well, we should probably move on to some package picks for the week. We asked Mark to bring along a couple of picks, and my only question is your first pick Android compatible?
Yes. So yeah, my first pick it's Uncertain by Matt Thompson, Matt TTT. And it's a Swift implementation of an old Microsoft library, not old, but a Microsoft paper from around 10 years ago.
I saw this package, yeah.
Oh, yeah. So it's about sort of rigorously treating uncertainty in a data type. It's just uncertain, generic across T. And it's really neat. It lets you, rather than, in your own code, when you're saying, oh, is this GPS coordinate close enough? Is it within or without? I'll just pick 10 yards or something like that, and then go with it and then iterate down the road. It allows you sort of to encode the concept of uncertainty into your data type. And so you can kind of treat it in a rigorous way, and you can compose it with other uncertain variables. It's a really neat idea. And yes, it does build on Android.
Yes, I saw it fly past. It was a few weeks since it's been released, I think. It looks like it's been in development for a month. So I think it was a couple of weeks since I saw it fly past, and it did catch my eye. It's kind of it's a slightly fun, but also it's not a frivolous package, but it is a slightly fun package.
Yeah, no, absolutely. And he has a great little Mac application that you can run that uses Swift charts and visualize various uncertainty algorithms and parameters to it, which is pretty neat.
Oh, that's great. I hadn't seen that. I had seen the package, but I hadn't seen the companion. I need to check that out again. That's a great package
it's pretty
suggestion.
Cool. I will go next with my first package pick for this episode, and it's Swift Complexity by Fumiyaka Tanaka. And this is a brand new tool rather than a code library for testing a couple of metrics against your Swift source code. So it tests for cyclomatic complexity in functions and cognitive complexity in functions, which if you've... I haven't seen this done for Swift before, although it may have been done. I just may not have come across it. But I certainly have seen it in both the JavaScript ecosystem and the Ruby ecosystem. So cyclomatic complexity is a measure of how many paths through a function there are. So if your function is lots of if statements, you're going to have a very high cyclomatic complexity. And there's also a measure here of cognitive complexity, which is not something I've come across before, but apparently it measures how difficult it is for humans to understand code. And this is a tool that will give you a representation of high cyclomatic and cognitive complexity in functions that you've written in your code. So you can run it as a tool against a single Swift file or an entire project if you would like. I tested this, and as is any tool that takes source code, I always point it at the Swift package index source. And I don't think it's designed for projects of that size, because it didn't manage to process the entirety of the package index source server source. It gave up after about 10 minutes. But also, you've got to think about how you'd actually use the results of this. You probably don't want to know about every single cyclomatic complexity issue all at once. And so one of the things that they do mention in the README for the file, for the package, is that you can integrate this into, for example, a CI testing scenario. So you could, for example, do a quick CI process that diffs the pull request, finds out what files have changed, and then runs it past each of those files individually and maybe gives that report or something like that. But I thought it was an interesting little package and one worth mentioning.
Did it suggest just to break the package index down to smaller components, like the Swift compiler does with it?
No, I may still have the error message in my console here. Actually, instead it told us we had illegal hardware instructions.
Ooh, all right.
Yeah, I can see. In the past, working with Java libraries, I've seen cyclomatic complexity analysis that would be used, like you said, in pull requests, and would compare the cyclomatic complexity before and after the pull request, and then say, oh, this really increases it by this amount. Maybe that should be a red flag. And I don't know how this cognitive complexity analysis works, but that sounds like it'd be a really interesting additional application. Is like, your pull request just made this a lot more difficult to understand. Maybe you should, consider simplifying it.
Yeah, I'm not sure I'd ever see any of these, and certainly in Ruby code, where there's a tool called RuboCop, which will happily tell you about your cyclomatic complexity problems. It's the kind of thing that quite often you'd look at it and go, actually, I'm kind of okay with that code, but yes, here there was a problem that we need to fix. So it's not something that I'd expect to see be a blocker to merging a pull request, but as an indicator of maybe you've gone too far in this function.
Right. My turn, I guess.
Certainly is.
And my pick is SQL Cipher by Micah Moore of Zetetic. And Zetetic is the company behind SQL Cipher. And this is the official Swift package for the project. I first learned about SQL Cipher when I was working for a bank quite a number of years ago now. And what it does, it is a fork of SQLite, of the official SQLite database library, and adds 256-bit AES encryption of database files. And then it obviously is immediately obvious why banks might be interested in that in particular, because they have like strong requirements on data security, like on-device encryption, all that sort of stuff. And so this is what this gives you effectively, a SQLite store that is encrypted and has the normal SQLite APIs, so you can use it with all your normal processes, your APIs and packages and stuff, and this is sort of taking care of making sure that the file at rest is encrypted. I'm not sure to what extent it is, encrypted in memory. It's quite extensive. There's a good documentation about what they actually do, how far this goes. Obviously, you need to consider how you handle your passphrases, because if you have a binary that encrypts the file, but then you have the passphrase sort of in your binary, that's not super secure, right? That is, I think we talked about this in the past with a package recommendation to deal with secrets in your code. But it is certainly better than just leaving the file unencrypted entirely. So if you have those needs, that's a great package to look at to deal with that. And it's probably one of the standard mechanisms actually to deal with encrypted database files on iOS devices.
Interesting.
And bonus, it, according to our compatibility matrix, it is compatible on all of them. So that includes the Apple platforms, Linux, Wasm, and Android. There we go.
So I've actually worked with them a little bit on this, and it's not actually compatible with anything but Darwin platforms right now, because they're shipping binary XC frameworks, which I think is not triggering it to fail.
Right.
It was somewhat urgent for them to get something out the door, because previously they had been distributing things via CocoaPods, and with CocoaPods sort of in imminent. CocoaPods is really winding down. They needed some other way to ship SQL Cipher support for Darwin platforms. But I am working with them actually on getting Android support via ideally having a source build.
Right.
I've been working actually on this for a while, both with them and with Gwendolyn Roof with the GRDB project whose SQL Cipher integration also relies on the older CocoaPods binary integration. So hopefully we will have a better cross-platform story with that right now, because it really is a de facto sort of gold standard for SQLite encryption support. Applications like Signal use it to, keep their local database of chats encrypted and things like that.
Yeah. I just realized now that you say that we do indicate that a package includes binary only targets, and I suppose our compatibility check fails in the sense that all it does is fetch the binary target and then does nothing with it. I suppose I just checked we have no error messages, but yeah, that's a gap definitely that we have there in our checking. There we go.
Yeah, fortunately on the horizon, we will potentially have support for binary frameworks for non-Darwin platforms in the not too distant future as static archives, right? Because there's no ABI stability for non-Darwin platforms yet. But even a static archive for a package like this would be sufficient. So, even if they will only ship a binary distribution, there is a potential for multiple compatibility with multiple platforms in the not too distant future.
Fantastic. Do you want to give us one last package recommendation or pick, Mark?
Yeah, I'm going to go with Lottie by Airbnb. That's a framework for rendering vector animations that have been exported from Adobe After Effects, which is kind of the industry standard for creating really fancy vector animations.
Yeah.
And Lottie is a fantastic application, super efficient. If you ever see really cutesy kind of animation-driven applications, one of the notable ones being Duolingo, those are almost exclusively driven using Lottie exported animations. They're very compact. They're vector-based, so they're always sharp on whatever screen. They're never blurry and things like that. And
most importantly, you don't have to worry about the creation tool, because there are, the most famous one is After Effects to create the animations, but the format that it goes into, I think it's what's the intermediate format?
It's a JSON. They call it body moving.
Body moving. That's it. Yeah. And so the biggest part of creating animations like that is how do you actually create them? And so it completely sidesteps that, letting other people do it, which I really like about this package and this technique.
Yeah. It's a great package. And you asked, if the other one the other one I mentioned built on Android. This actually does not build on Android because it uses sorry, my brain is Core Animation for its implementation of animation, which of course is an Apple-only framework. But there is a Kotlin side to it, this Lottie Kotlin, that implements them using Android's, canvas vector rendering animation. And that's actually one of the popular packages for Skip, is one that bridges between these two, so that you can, with your Skip application, you can ship a Lottie animation, and on iOS it will use the Lottie iOS core animation package, and on Android it will use their equivalent Kotlin implementation.
Well, that's great. I have a feeling I didn't stop you because I wasn't 100% sure, but I have a feeling we have had Lottie on the podcast before.
Oh, okay. I did go through the past 20 or 30 and I didn't see it, but I didn't exhaustively go through them all.
Well, there are some that have been lost to time. Yeah, we started this as Twitter Spaces when Twitter Spaces were a thing, and so I think we managed to capture some of the recordings from those, but certainly not all of them. So you are absolutely forgiven. Plus, this is episode 61, and so I think it's high time that we highlighted Lottie again.
Real-time follow-up. It was in episode 17, so that's that is in the distant past. It is well worth a re-mention.
Yeah. Well, and with that, we shall call it another episode. So I'd like to thank Marc so much for your time coming on and talking about the Android Workgroup and Skip tools. And we will be back in a few weeks with more package picks and some news from Package Index, I guess.
All right, thanks for having me.
Thanks, Mark, and see you in 2 weeks, or next time rather. Bye-bye.
Thank you. Bye-bye.